дорогие друзья и коллеги. Unfortunately, my Russian is not good enough to tell you everything in Russian. I will also try to speak slowly, and so I hope you can translate nicely everything. Okay.
Я постараюсь говорить помедленнее, а вы постараетесь хорошо переводить.
Yeah. What I would like to tell you is about stories, in fact.
То, что я хочу вам рассказать, это, в общем-то, истории.
Stories which are linked with what I learned from my old times.
Истории, которые связаны с тем, что мне удалось узнать когда-то очень давно.
To today.
И истории, которые я знаю сейчас.
I started to work for my PhD in the 60s, and it was about ice core.
Я начала работать над своей докторской работой в 60-х и по теме гляциологии.
And I would like to explain you how a young scientist starting to work in a specific subject became interested in things which are of interest for nations, for the life, and for the societies.
И я хотела бы рассказать вам, почему молодые ученые интересуются этой темой и как она влияет на нашу с вами жизнь, на государство, на людей, на наше будущее.
So, we'll first show you something I like, because I spent many time on the field and in the cold room to look at air bubbles in ice.
Сейчас я хочу показать, что мне действительно нравится, потому что я провел много времени в холодных помещениях, работая над воздухом, запечатанным в толще арктического льда.
You can see for this thin section of ice that in about 20 grams of ice, it's not a lot, 20 grams of ice.
Вы можете увидеть тонкий кусочек льда, здесь всего около 20 грамм.
That you take in Antarctica or Greenland.
Такой образец вы можете взять в Антарктиде или Гренландии.
You have several thousands of very, very thin air bubbles, about 1 millimeter diameter.
В таком кусочке заключено огромное количество маленьких пузырьков льда, микроскопических практически. Воздуха, простите.
And of course, and I hope I can see it's probably a lot of students around. If you become excited, but not only excited, but fascinated by something that you observe and you would like to understand this, it's really, all your life at this time, at least the time you spent in the lab.
Как я вижу, здесь очень много студентов, и если молодой человек очень чем-то заинтересован, то он готов проводить часы в лаборатории.
And when I started, we had no idea what we will find in fact, in these air bubbles.
И когда мы начали, мы не имели никакого представления, что же мы можем найти в этих пузырьках воздуха.
Except that probably 1 century before, a man did a funny, difficult work, and we knew, when we were looking at these bubbles, we knew about his story.
Разве что мы знали о человеке, который век назад сделал очень забавные наблюдения, и мы знали об этом, о его исследованиях в этой области, исследованиях пузырьков воздуха.
This guy is Svante Arrhenius from Sweden, living at the end of the 19th century.
Это шведский ученый Сванте Аррhenius, который жил в конце 19 века, начале 20-го.
Was a scientist, and scientists at this time, they were not a specialist only in one subject.
Он был ученым, но он не был специалистом в каком-то одном предмете.
He was interested and good in chemistry. Sorry.
Он интересовался химией.
Okay. In chemistry, he got the Nobel Prize in chemistry.
В химии он получил Нобелевскую премию.
But he heard about a fantastic story.
Но он слышал совершенно фантастическую историю.
He heard that it was not good reason to understand why in the Alps big stones, boulders, were able to go to the valley, for instance.
Он знал, что в Альпах существуют камни, которые
big. So if you go to the valley in the Alps, in Switzerland or France, you see a boulder, what we call boulders, are very, very big stones, you know. And the question was, how such very big stones has been transported to reach the valley?
Если вы окажетесь в Альпах, то внизу в долине можно найти огромные камни. И существовал вопрос, как они там могли оказаться.
One theory at this time was easy. You know, you get a lot of rain, and this can explain that practically all these big stones reach the valley, just because everything was flooding.
Одной из теорий было то, что все произошло очень простым способом. Камни оказались внизу, из-за наводнений было много дождя, и они спустились вниз.
And in a way, that was a story, you know, inspired by the Bible.
И эта история подкреплялась и Библией.
Yeah. And Svante said, no, should be something different. And at this time also, it was well known that 20,000 years ago, for instance, it was an ice age.
Однако Аррhenius считал, что, возможно, есть и другое объяснение. Также было известно, что 20 тысяч лет назад был ледниковый период.
And one of the ideas was, well, finally, you know, just the glaciers at this time were stronger, bigger, and able to bring the stones until the valley, just by advancing the glaciers to the valley.
Его предположение было в том, что в то время ледники были намного мощнее, сильнее, и они могли спустить эти камни, принести эти камни в долину.
Okay, if it is true, then why 20,000 years ago it was a lot of ice covering the Alps, for instance?
Но если это правда, почему же так много льда было 20 тысяч лет назад?
And a branch of scientists in different countries, I think many in Europe, said, well, you know, it's quite clear what is changing the climate from an ice age to a warm period, what we call an interglacial, is just because, you know, the insolation, the energy coming from the sun was changing, and it was at this time enough knowledge to calculate what kind of change could have occurred in the position between the position of the Earth and the relative position of the Earth versus the sun.
В то время многие ученые работали над этой темой, в первую очередь европейские ученые, и задаваясь этим вопросом, они предполагали, что со временем менялось количество энергии, которую давало Солнце Земле, и эти изменения.
And just if 20,000 years ago the insolation increased during the summer, for instance, it was so strong that practically, you know, the glaciers, the ice sheets also started to decrease in volume.
Солнце было настолько сильным, что большое количество льда просто растаяло.
And Svante disagreed with that. He said, well, maybe, of course, it is possible, but I think the carbon dioxide in the atmosphere was a big player.
Однако Арениус был не полностью согласен с этой теорией, предположив, что углекислый газ играет не последнюю роль в этом процессе.
So to make a long story short, in fact, in 1896, he published his famous paper saying, well, you know, I made a calculation. I am able to calculate how much CO2 concentration should change, by how much the CO2 concentration in the atmosphere should change, to induce a change in temperature for about 5 degrees C, which will make that we will melt effectively the glaciers and the ice sheets.
Он опубликовал свою работу с результатами своих исследований, которая как раз доказывала свою теорию о влиянии углекислого газа на таяние ледников.
And this brave Arrhenius, he made the calculation, and he said at the end of the paper, well, it took me 1 year to calculate for each portion of the surface of the Earth by how much the temperature will change if we double, for instance, or cut half of the CO2. And this calculation was so boring that I will never in my life continue to work on this subject.
Также в статье он опубликовал свои подсчеты, над которыми он работал целый год. И после опубликования своих подсчетов он сказал, что они были настолько тяжелыми и неинтересными, что над этой темой работать он больше не будет.
But the result was that you have just to cut your CO2 or to decrease your CO2 concentration by a half, for instance, and then you will have the condition of the ice age. And this explains for me, for Arrhenius, the reason why we started to finish with an ice age and to go to an interglacial.
Он предположил, что если сократить количество углекислого газа в атмосфере вдвое, то мы вернемся к ледниковому периоду. И профессор Рейно тоже поддерживает эту точку зрения.
But the interesting thing, you know, he said at the end also, well, it was not my subject, but just imagine, because the man will burn coal or oil or things like that, I guess that if we double the CO2 in the atmosphere, starting from the level at the end of the 19th century, at some stage in the future, we will increase the temperature at the equilibrium, we will increase the temperature by 5 degrees. He said that.
Но если мы продолжим увеличивать количество углекислого газа в атмосфере, то температура существенно повысится.
So this is an image of the boring calculation. By the way, you know, the big computer used today to study climate, they do the same calculation in about 2 minutes. And for him it was 1 year. But the results, as you will see, of this big simulation are very close, not very different from what he obtained. But we know that today that it was something wrong in the calculation of Svante. I think it's interesting in terms of how science, you know, is building up, sometimes collapsing, but sometimes really making big discoveries.
На экране вы как раз можете увидеть те самые так называемые скучные подсчеты. Интересно, что сейчас те же самые подсчеты можно сделать на компьютере в течение нескольких минут, на что потребовалось год профессору.
This is just to summarize what I said. And if you are interested, you can have copies of these things.
Я хочу подвести итог тому, что я сказала, и если вам интересно, вы можете найти эту информацию, переписать или спросить.
Yeah, here's the same thing. So you know when he said 5 degrees C for a doubling of CO2, now the state of the art is to say, and we have a certain uncertainty in the calculation, it's between 1.5 and 3.5 or 4 degrees C. So he was in the upper limit of the state of the art today for estimating the sensitivity of the climate to doubling of CO2.
Подсчеты Аррheniuса о том, как будет выглядеть температура в настоящее время, если углекислый газ увеличится вдвое, были очень близки к тому, что мы имеем сейчас.
At the same time, I started with colleagues to look at the small, teeny bubbles in the ice.
Я начал работу со своими коллегами над пузырьками воздуха, запечатанными в льду.
At the same time, another story came from the middle of Pacific Ocean in Hawaii on the volcanoes Mauna Loa.
В то же самое время пришли новости из Тихого океана с Мауа-Лоа, Гавайи.
In 1958, an American scientist called Dave Kelling was fighting a lot with the administration because he had for several years the idea, well, if we measure today in the atmosphere, at every minute, the CO2 in a good spot at the surface of the Earth, we may see if today the CO2 is changing in the atmosphere.
В 1958 году американский ученый Дэв Келлин работал над темой измерения углекислого газа и предположил, что
if he measured the result of his work, the result of his work turned be
The result of
his work.
his work. So that's his curve.
Сейчас вы видите результат его работы.
How do you use a pointer on that? Whoops. Okay, that's I can show with my finger. That's maybe okay. So started in 1958. No, but that should work also. Let's see. It's not here. It's here. It's here. Yeah. Okay. 1960. 1958, the start of the measurements. I will come back to that because I will show again this curve. But when we were investigating the ice at the beginning, when I was a young scientist, it was here, you know. And already we had the feeling that by the first measurements at Mauna Loa, that something was changing year by year in the atmosphere.
Исследования были начаты в 1958 году. На экране вы видите отметку 1960. Все молодые ученые в то время, работающие над этой темой, были уверены, что результаты, полученные в Мауна Лоа, будут представлять ценную информацию.
So, at this time, in the 60s, we knew that maybe CO2 can affect the temperature of the world, and maybe CO2 is today changing each year. So that was the two things we knew when we started with the ice.
Тогда, в 1960-м, мы могли предположить только две вещи. Мы знали, что углекислый газ влияет на температуру, на климат, и то, что количество углекислого газа в атмосфере меняется.
Okay, so I will skip with that, but so during 10 years,
в течение 10 лет
we were in two labs in the world.
Мы работали в двух лабораториях.
One in Bern, Switzerland.
Одна в Берне, в Швейцарии.
The other, to simplify, I will say in Grenoble, France.
И вторая во Франции, в Гренобле.
We really, in fact, it was not Grenoble. I'm sorry because we were in Paris at this time. But in any, no, sorry.
Вообще-то это был Париж, потому что именно в то время мы были в Париже.
And we really started to try to extract the gas of the air bubbles by melting the ice under vacuum.
Именно тогда мы начали работу по извлечению газа, который был словно вакуум во льду.
And we found completely erratic results.
И мы получили достаточно полные результаты.
It's to say we found something which was really too low to be really the atmospheric composition, because our dream was that maybe in the air bubbles, when the snow is forming, trapping the air, maybe we will be able to reconstruct the past variation of the CO2 in the atmosphere.
Мы точно не знали, что мы можем обнаружить, но надеялись на то, что, возможно, воздух, заключенный в в этом вакууме, в этих пузырьках может также характеризовать климат миллионы лет назад.
And well, we were nearly thinking to skip with this problem and to say we will never be able to do that.
Однако мы не знали, получится это или нет, и готовы были практически отказаться от этой идеи.
Until the time where, with good reason, we said, well, we stopped to melt the ice. Of course, when you melt the ice, the gas is just going out, you know, and you can collect it. But we said we should stop, probably something is wrong in the extraction method.
Изначально мы пытались получить этот воздух, просто растапливая лед. Однако мы поняли, что такой способ ни к чему не приведет, и нужно попробовать что-то еще, какой-то другой метод.
And we had the idea, we had the idea, instead to melt the ice, to crush the ice under vacuum. With small ball, we put metallic ball in a container. We close it. We make the vacuum. We shake strongly the system, and after 30 seconds, the ice explodes. Open the bubbles. The gas rise. And we have just to collect the gas without to melt.
Вместо того, чтобы просто топить лед, мы положили кусочки льда в специальный аппарат, внутри которого находились металлические шарики. Очень сильно этот аппарат очень сильно встряхивал содержимое, и происходило что-то вроде небольшого взрыва. Таким образом, газ, находящийся внутри, поднимался наверх, и все, что нам оставалось, это только собрать его.
And you know, in the life, you have some time to keep with your ideas and don't give up. So that was really the way to do. And we found, just to illustrate, that was the first publication with this extraction system.
В то время все, что в первую очередь, что мы делали, это собирали различные идеи и не сдавались. И вот наша первая публикация.
And we extracted from an ice core in Greenland, in Antarctica, sorry, the gas, and we found, you know, that you see here, this is a temperature curve which shows that this ice has been formed during an ice age, this one has been formed during the last 10,000 years, and if you measure the gas, at this time we had quite a lot of scatter, but it was clear that we found a large change of CO2 when you go from ice age to interglacial ice.
Таким образом, получив газ из ледяного керна, мы получили наглядные результаты того, что климат того времени кардинально поменялся с климатом, который мы имеем в настоящее время.
Yeah, and then, as you can see here, so Arrhenius' prediction was, you know, you should have about 40% of the CO2 less during the ice age, and we found through these measurements you have seen, which were pioneering work, also that in the bubble of ice you were able to demonstrate that CO2 concentration in the atmosphere during the ice age was about 40% less than during the warm period.
Если в конце XIX века Арениус предположил, что после ледникового периода произошло потепление в связи с увеличением углекислого газа, то мы в конце 20-го, исследуя пузырьки воздуха, запечатанные в толще антарктического льда, обнаружили концентрацию углекислого газа и предположили, что это также повлияет на будущее нашего климата.
So just one word to explain why if you crush the ice, you have the good signal, and if you melt the ice, you have a bad signal.
В чем же разница, почему такие плохие результаты при растапливании льда и достаточно четкие и конкретные при способе, который использовали ученые?
It's because even if the ice is very, very pure, you have always a little bit of carbonate, which are coming from the air, and if you melt the ice, you dissolve the carbonate and you produce extra CO2, which makes that you are not getting the original signal of the atmosphere.
Все дело в том, что какой бы чистый ни был лед, так или иначе всегда существуют примеси, которые не позволяют дать нужных четких результатов.
So that was 1980. Then, for the last 20 or 30 years, it has been a lot of new results about CO2, and now we have a very, very long record of CO2 over the last 800,000 years. 800,000 years, it's quite a lot, nearly 1 million years.
Это были результаты исследования 1980 года, но в течение всех следующих лет мы продолжали работу и измерение углекислого газа в атмосфере. И можно говорить о том, что содержание углекислого газа менялось на протяжении многих миллионов лет.
And I am very pleased to show here in this country an extraordinary input by the work of the driller. That was a Soviet driller at this time, but they continued now to drill at Vostok. The group of St. Petersburg, Leningrad at this time, has been really, the best, I would say, the best record in terms of depth, and working a lot to get a good core, and finally, that was really something, the curve I will show you after that is really something which is extremely important in the history of this science.
Я с удовольствием представлю вам результаты нашей работы на станции «Восток», где мы работали совместно с российскими, советскими учеными из Санкт-Петербурга, в то время Ленинграда.
By the way, okay. By the way, you see, it's not oil drilling, it's ice core drilling. You see, you have several attempts. It was a long story. I will not speak too much about this very, very long story in nice adventure. But finally, what will probably remain in the science for a long time is the first time that we got from this ice core a record during 400,000 years. 400,000 years with 4 ice ages and 4 interglacial, showing the music of CO2 in the atmosphere, the rhythm of the CO2 into the atmosphere.
Я не буду долго рассказывать о наших исследованиях, скажу только, что исследуя ледяной покров, ледяной керн, мы получили показатели ритма количества углекислого газа в атмосфере.
And starting from first, the blue curve is CO2, the red curve is methane. Methane is another trace gas which is greenhouse gas and which should impact also the climate. And for the first time, we understand really that it was a sort of nice marriage, It's not as all the marriage, it's not completely perfect, of course. But nevertheless, each time that the climate was warm, CO2 and methane were showing high concentration for 100,000 years. Then when we were cooling the climate, going to an ice age, both CO2 and methane decrease, and so on. And you have this rhythm, high values of CO2 and methane, 2 important greenhouse gases, really singing together with the climate. It don't tell you who is first, who is second, and as I will tell you a little bit later, this is not the right question, but just this has been really something important. So then,
excuse me, can I translate?
Yeah, sorry. I forgot you. So that's all. I will sit.
На схеме вы можете увидеть синюю и красную линии. Красная – это метан, также парниковый газ. Синяя – это непосредственно углекислый газ. Измерения показали то, что каждый раз, когда температура опускалась, содержание углекислого газа и метана также сокращалось. Соответственно, когда температура повышалась, повышалось и количество этих парниковых газов в атмосфере. Соответственно, мы можем увидеть непосредственную связь количества этого газа в атмосфере и влияние этого на климат.
But I forgot to tell you the most important thing. Well, maybe not the most, but a very important thing. If you look again, I'm bad with that. Okay. If you look at this CO2 record, today we are here. You see, in about 250 years, the CO2 went up, completely out about the variability. So this is true for, we know now, this is true for 400,000 years. This is also true for 800,000 years. So it's to say that carbon dioxide and methane in the atmosphere have never been so high in concentration than today compared to just to say roughly 1 million years. Okay. So that's important.
Самое важное, что я хочу вам здесь показать, это то, что количество углекислого газа в атмосфере сегодня особенно высоко. Оно не было так высоко еще никогда. Подъем произошел за последние 250 лет.
Okay. So I think I will skip a few things. I will skip this one. Just to show you that the Vostok ice core provided much more information about change in dust content, change in temperature at high elevation, at high latitude, and so on.
Я пропущу несколько слайдов. Просто хочу сказать, что такое исследование дает достаточно полную картину состояния атмосферы.
But now you should ask me one thing: is okay, but are you not a little bit crazy? Because when you extract air from an ice samples 40 gram, how are you sure that it represents really the atmospheric composition at this time? Because what you measure is in ice, in air bubbles, or in the ice which is now in the air which is now trapped in ice. So, how to believe you? Why are you so sure?
Ну и вы меня, наверное, спросите, как я могу быть настолько уверен, имея исследования, полученные всего лишь из 40 граммов льда и содержащегося в нем воздуха, достаточно ли данных собранных?
And one of the response to this question is the fact that we found exactly the same thing in different ice core in Antarctica for the more or less the same age, but in sites with completely different conditions of temperature accumulation. That's the first thing. And all the time we found exactly the same change. So it's not only one core, it's not only one location, but it's something we found at large scale on the ice sheet.
И ответ в том, что мы исследовали не единственный ледяной керн, а брали образцы в разных местах мира примерно одного периода и получили абсолютно одинаковые результаты.
Then we made in the laboratory investigation of diffusion of gases through the ice lattice, through the ice crystals.
И затем мы уже работали в лабораториях и продолжая исследовать кристаллы.
Yeah, we can say crystal interaction, not only diffusion, but also absorption, things like that.
Взаимодействие кристаллов, не только отдельно их.
Okay, so we know these parameters quite well, and I generally, but I may be wrong. That's just a sort of picture that I give when I say that. But I normally said, today we are living here in Tümen. With our nice technology, we are building a box. In the box, we trap, very, very pure, with very, very pure metal and so on. We trap some ice, and we say, we would like to have the people living in Tümen in 1 million years from now, if there are still some people, we would like that they are able to know what was the composition now in Tümen. And I always said, they will probably not have a good result as the ice, because the ice is extremely pure, in fact, especially in Antarctica. You have very pure interaction between the pure ice, and gases.
Можно получать результаты и даже здесь, в Тюмени, через 1 миллион лет, если кто-то будет жить здесь, тоже смогут собирать данные. Однако в Антарктиде можно получить самые чистые результаты.
Okay, I'm sure we can discuss that, but it's an interesting subject.
I'm not sure.
No, I'm not sure also, as I said at the beginning, but it's clearly a very, very, very pure material. Okay.
Это очень чистый материал, без примесей.
I will be interested to discuss with you after that. Okay, I skip that is just to show you that we have now a very long record for 800,000 years, mainly because we drill another core in Antarctica, at Epica, Dome Sea, central part of Antarctica. It's a European program. And maybe I would like just to say what is really the lesson of Antarctica is. It's just a conclusion, very difficult to go in details. I will be very happy to discuss that with you later. But clearly, from what we have from the ice, the present-day atmospheric concentration in CO2 and methane have been unprecedented during the last 800,000 years.
Я пропущу подробные результаты наших исследований, просто хочу, чтобы вы увидели, насколько подробно они, и мы проводили исследования воздуха, собранные за многие годы, и если вас интересует, то подробнее мы сможем поговорить об этом позже. Я с удовольствием это сделаю.
And I will say, again, it's just the state of the art today. Maybe the knowledge will change in the future, but really now, most of the results in the paleoclimatology go this way, that in fact, if you would like to go from an ice age to a warm period, like the Holocene period, it's clear that you have an external forcing, which is the insolation.
Если говорить о переходе из ледникового периода в теплый период, то, конечно, в первую очередь мы будем говорить о влиянии Солнца.
If you calculate in terms of energy, the energy of the change in insolation, and you can do that quite accurately.
Если мы будем измерять энергию, которую дает нам Солнце, то можем получить достаточно точные сведения.
You will explain a change of about a few tenths of a degree, 0.2, 0.3 degrees C, due to the change in insolation.
Мы можем увидеть изменения около 2 или 3,1 как раз из-за солнечной энергии.
But what you observe from the paleo data is that the change is from glacial to interglacial, 10,000 years of change, about 5 to 7, maybe more 5 degrees C warming when you go from glacial to interglacial.
Если мы посмотрим на период в 10 тысяч лет, мы увидим, что температура изменилась 5-7 градусов, повысилась.
So you have to think about amplifiers, big amplifiers, and following Svante Arrhenius' idea, probably about half of the change, the rest of the change is to say practically 5 degrees C, is due to the change in greenhouse gases, CO2 mainly, but also methane.
Мы можем сказать, что, возможно, такое потепление произошло как раз из-за парниковых газов. В первую очередь это углекислый газ, но также и метан.
And the rest, which is also about half of the change, due to the fact that the ice sheet in the northern ice sheets are retreating, disappearing except Greenland, and affecting because of the albedo effect, affecting also as a positive feedback the change in temperature.
Из-за изменения температуры ледники отходят, ледники сохраняются по-прежнему только в Гренландии.
But I am sure you are more interested about what happened today. Okay, so we will focus on that now.
Но я уверен, что вам интересно в первую очередь, что происходит сегодня, и на этом я и остановлюсь.
So, сегодня, as you said, if you look now, okay, if you look here at the best attempt to describe the change in temperature since about 1850 to today, and you would like to have a global signal, is to say something which average all the regions, and I will come back to that later. But if you would like to have this, it's easy, more easy to do that. You see that, in fact, you have something relatively flat here with, of course, interannual change, quite important interannual change. Then, starting 1900, an increase in temperature, which seems global, then a sort of plateau, slow down, then an increase again for the recent time, and then maybe a sort of plateau, but we know a little bit more about that now. That's one thing to look at that. It tells you one thing. It is that, you know, to look year by year at the average value is very interesting. It shows you that all the variations that you see are real. It means that, yes, you have interannual variations, but if you would like to know if it is a message which will last for a little bit more than 1 year, then you have to average over 10 years, even better 30 years.
На графиках, которые вы видите, как раз показаны изменения температуры, начиная с 1850 и до 2012. Несложно увидеть, что температура продолжает повышаться. В некоторые годы происходило понижение температуры, однако общая тенденция понятна. Температура с каждым годом повышается.
So if you do that and you average over 10 years, it's what you see here. So we took all these results, average over 10 years. So that's all the things you can see here, with, of course, a certain a certain error on the determination. So you recognize the main trends, of course, but the interesting thing is that the three last decades, the last 30 years, sorry.
Но самое интересное, на что мы должны обратить внимание, это изменения, произошедшие в последние 30 лет.
So definitely the last 3 decades are getting to be the warmest during this time period. Always keep in mind that the scale of this change is maximum change is 0.8, 0.9 degrees C, compared to glacial interglacial change, which are 5 to 7 degrees C.
В последние 30 лет температура достигла рекордной отметки по сравнению с прошлым. И измерения мы можем увидеть на схеме, что исчисление начинается с нуля.
But also keep in mind that glacial interglacial change lasts 10,000 years or more.
А ледниковый период длился
How many years?
10,000 years.
10 тысяч лет.
And that's what I am showing here happened in less than 2 centuries.
А то, что я показываю вам, произошло за период меньше, чем в 200 лет.
Okay, now, is it reasonable to look at average, mean values, average values, and so on? Well, and global signal.
В глобальном смысле мы можем увидеть изменение температуры на такой карте.
So to answer this question, what you can do is look at all the data you have, but this time not average, but looking at all the records that you got. And it's what has been plotted on this map between 1901 to 2012.
На этой карте вы можете увидеть все сведения, которые были собраны. Изменение температуры с 1901 по 2012 год.
Remember the color code. Here it's refreezing over this period. Here it's warming during this period.
Разными цветами показано, насколько показана температура. Голубой – это самая холодная температура, и фиолетовый – самая теплая, самая высокая температура воздуха.
And also you have white regions.
Также вы видите белые участки.
White regions means that we have not enough data to statistically take this input for your record, but there are not so many on the map.
Это значит, что у нас нет достаточно сведений, чтобы обозначить результат на карте.
And yes, we have some regions, North Atlantic, around here also, around Texas in this area. We have some regions which are cooling, probably slightly cooling over this period.
На карте вы видите, что в североатлантической части есть места, где температура понижается.
But if you are not colorblind,
но если вы можете различать цвета,
you should accept that most of the map
вы должны согласиться с тем, что большая часть карты красная.
And I am colorblind and I see green, but it's red.
Я не различаю цвета, и мне кажется, что это зеленый, но это красный.
No, that's true. I am. I should confess that. Okay. Well, other interesting thing. So, yes, the conclusion is that, yes, the planet is warming nearly everywhere.
В заключение, результаты того, что мы видим, можно подвести итог. Планета действительно становится теплее.
So the scientific community did the same thing for precipitation. This map is precipitation.
Эти две карты показывают ежегодное изменение Земли.
And it's much more difficult to have a good map for precipitation. We have much less data, in fact, for precipitation.
И эти карты очень сложно составить, потому что у нас нет достаточно сведений.
But if you look at this map, so you have to compare what had happened if we average during the 20th century or only the second half of the century. And you see that clearly during the most recent period, you have exaggeration, or finally some regions are really increasing the dryness, or others are definitely also increasing the amount of water reaching the soil.
Мы можем увидеть, что не произошло таких изменений за 100 лет, но они очень видны за последние 50-60 лет.
And the bad news, if it is continuing like that in the future, the bad news is definitely that the regions which are dry will become more dry, and the regions which are wet will become wetter.
Наглядно видно, что те сухие регионы, где отсутствует обильное количество осадков, становятся еще более сухими, а регионы, где количество осадков достаточно большое, картина становится еще более наглядной.
Okay, so to summarize, about 0.9 degrees C warming on the mean during the 20th century, or a little bit more. Then we can see something interesting. It appears that it's not too much the day temperature which is increasing, but more the night temperature which are not decreasing. So that seems to be something which reflects the reality.
Кстати, очень интересный факт. Не дневная температура увеличивается, а ночная температура не снижается.
The summer heat waves, what we call canicule in my country, but which is not canicule in Russia, but heat waves, so it's really the period with very, very high warm, becomes more frequent. It seems that we have more and more of these periods.
Теплый период в течение года становится длиннее.
And that's highest warming rate. The part which is warming more rapidly is the Arctic. I think this is well documented. It's what we observe.
И особенно температура повышается в Арктике.
Okay. Here I will go very quickly because that's the other consequence. We talk about temperature, we talk about precipitation.
Здесь я буду очень краток. Мы поговорили о температуре, мы поговорили об осадках.
Okay.
И сейчас поговорим о том, какой вывод мы можем сделать.
But then we have many things which are changing, you know. The sea level is increasing, that's clear. Also the change in the heat of the temperature in the ocean is increasing. There are many things. As you know, the Arctic sea ice is decreasing. Many things are changing, including the amount of snow which fall, which accumulate and stay on the ground at the month of June, is also completely decreasing. So there are a lot of things in the Earth. I will go very quickly on that, just for the pleasure, because it's not very far from where I live. It was a very nice design from Glacier d'Argentière near Chamonix, made in 1860, and that's what you see on the left. And one, yeah, please. Let the people have a look on the picture.
Очень многие вещи также меняются. Это и уровень воды в океане, и температура воды в океане, количество льда количество выпадающего снега. А сейчас вы можете увидеть две фотографии сделанные. Фотография местности, где я живу. Это одна фотография, сделанная в 1860-м, и вторая достаточно недавняя фотография. И вы можете увидеть, как ледник сдает свои позиции.
Yeah, спасибо. No, you said more than I said, but it's good. Okay, so finally, warming seems quite obvious. Then, oceans, not only the atmosphere, the oceans are warming. And that's something that we know more and more, because at the beginning we were able to measure the warming during over the first 75 meters, and now we are able to get information about the first 700 meters and soon the 2000 meters.
Итак, температура воды в океанах также увеличивается. Раньше мы могли делать измерения только на глубине не более 75 метров, но сейчас можем ходить гораздо глубже.
But probably one of the indicators which is the most powerful, because he is integrating a lot of physics, a lot behind, that's the sea level increase.
Итак, уровень воды поднимается, и это является одним из существенных признаков.
Sea level has increased continuously.
И поднимается он постоянно.
By 1.7 millimeters, 2 millimeters to simplify, each year at the beginning of the 20th century.
С начала 2000 года ежегодно уровень поднимается на 1/10.
And today it's
на 1,7, извините.
And today it's increasing by 3.2 millimeters per year. And it will probably continue to increase more rapidly, because the new thing is that in Antarctica and Greenland, we observe today, since about 5 years or something like that, ice flow, ice river, and the speed is increasing a lot. And it's likely that the sea level will increase more rapidly during the coming century because of that. Yeah?
А сейчас уровень воды поднимается еще быстрее с каждым годом, и мы можем предположить, наши исследования это доказывают, что уровень будет подниматься с течением времени еще быстрее.
Another interesting aspect is, the CO2 is increasing, and we can question what is really the impact of CO2 on temperature and so on. But the CO2 is increasing not only in the atmosphere, it's increasing inside the sea. And this is illustrated, no. This is illustrated by this figure here, where you have, which show during the recent period, because we have no measurements before, that the PCO2, the amount of CO2 is increasing in the upper part of the ocean, and of course the pH is changing, and that's a real problem, of the acidification of the ocean. So that's another problem, or another question, or another interesting parameter, as you prefer, which is playing a role.
Количество углекислого газа увеличивается не только в воздухе, но и в воде. Мы можем увидеть на графиках его увеличение. Это очень интересно. Мы стали делать эти измерения количества углекислого газа и pH в океане совсем недавно, и результаты можете увидеть на экране.
Just to finish with that, I was plotting here these two, what I call iconic, but I don't know if it is a good word, but in quote at least, figure which really had a strong impact on the thinking about carbon cycle and climate change. One is Vostok on the right, and Mauna Loa curve in the atmosphere, and I think that's really two curves which are important in this field.
Результаты, которые вы можете увидеть в графике, это достаточно традиционные, можно сказать, канонические линии, и график был сделан на основе результатов сведений, полученных на станции «Восток» при изучении ледяного керна.
Of course, now the question is to know why the climate is warming. Okay, so
и сейчас вопрос в том, почему же происходит потепление климата.
So you have several factors we know have and should affect even today the climate.
Существует несколько влияющих факторов.
One is volcanoes.
В первую очередь это вулканы.
I will show you something quickly about that.
Я покажу вам кое-что об этом тоже.
The second thing is the solar activity. It's not anymore the position of the Earth versus the position of the Sun. This time it's something which happened at the surface of the Sun.
Вторым фактором является солнечная активность и изменения, происходящие на поверхности Солнца.
And this begin to be well documented also.
И сейчас тоже это активно исследуется.
Then you have the human activities.
Ну и человеческая деятельность.
At least since the pre-industrial time.
В первую очередь до индустриализации.
And one thing which is very important, because you can warm for specific reason in one spot or another because the CO2 increase there and so on. You can do that. But the atmosphere and the ocean are not inert.
Мы можем может нагреваться то одна часть планеты, то другая, но вода в океане не инертна.
They are taking at the source of a change of climate the heat, transport the heat everywhere or in different places. One example is El Niño effect. There are other examples, slow down the for instance, the Gulf Stream, things like that. There are several, and also the change in atmospheric dynamics.
Ветры очень влияют на воду в океане. Вода перемешивается, и тем самым измерения могут быть различными.
So I can show you different things for all these things, but let's go directly to that. Sometimes it's difficult to understand these graphs, but nevertheless, the message behind is to say, if I can be free, yes, is that we are able, since I could not, I think it's since 1750, we are able to calculate for each of the components, CO2, methane, ozone, albedo, aerosols, all these things have an influence on the climate. And also the sun, and volcanoes. So we are able to calculate it doesn't mean that it is only this, because this is a direct effect. It means then you have also some long-term feedbacks, which are not included in that. But I'm talking about short-term impact. For instance, for CO2, that's what? That's water vapor which is produced, that's clouds, that's sea ice, that react very quickly at a change produced by CO2. Difficult to translate all this. Huh?
На схеме, возможно, ее сложно понять, но то, что я хочу сказать, это то, что мы делаем сегодня. Ученые могут делать совершенно различные измерения практически всех газов и влияние их друг на друга. И еще я сейчас говорю о влиянии в течение короткого промежутка времени, не длительного периода.
So we are able to express this in a watt per quadrat meter or something like that. More interesting, if we do that, put this in the big models, which are able, with difficulties, but that's the best thing we can do, to describe what should have been the evolution of the climate since 1900 and compare with what is observed. And I think that's an interesting exercise. So if you look in the bottom curve, what is observed, you have seen this several times, this is a black curve. Now, if you take into account what I call natural forcing, and natural forcing, when I say that, it's not completely correct, you will understand why, but it's mainly, and this is correct this time, it's mainly sun activity, solar activity, and volcanoes. We are able to really to correct for that and put this into the model and say, well, the Pinatubo was impacting and so on and so on. We can calculate the physics, the change in atmospheric composition, the change also in sulfate, for instance, the change in atmospheric circulation, oceanic circulation. If you do that, you are able to reproduce what is observed more or less, not too bad. Probably not this, but the rest, except here. We are not starting 1970, we are not able to reproduce what we observe. I should also say that, of course, the model, there are several models, not only one model, there are several models, and there are uncertainties, and you see that's why you have this weak envelope here. Okay. Now, if you try to do the same thing, but you add human influence, what is that? That's mainly greenhouse gases, aerosols, things like that. And спасибо.
Графики показывают, самое главное, что мы можем увидеть на графиках, это то, что это влияние, человеческое влияние, влияние человеческой деятельности и так называемых природных факторов, к которым относятся солнечная активность, вулканы и так далее. И на графиках мы видим изменения, начиная с начала прошлого века.
And then, if we add the human impact, mainly greenhouse gases, aerosols, you see on the record which is on the top, or the curve which is on the top, that's practically you are able to much more to simulate what is observed. So I think that's the best thing we have. That's all. So we can discuss a lot, but it's a sort of state of the art. It don't mean that the thinking about that will stay exactly like that, but well, it's what we have.
На эти темы можно говорить очень много, они активно исследуются, но вот, в общем-то, то, что я хотела сказать вам сегодня. Но обсуждать это можно еще очень долго.
Okay, so we will skip that, go to that. Well, also one thing the community do, and this is interesting because scientists are now trying to simulate what will be the climate during the next century. No, the present century, until the end of this century. So let me show you two things.
Итак, что сейчас для нас особенно актуально, над чем работают ученые, это моделирование картины, какой климат мы будем иметь в течение 100 лет, ближайших 100 лет.
So it's a sort of consortium which has been created inside the labs, inside the specialists working on that. And they all develop different models. So it's not one model. For instance, when they would like to reproduce the temperature which has been observed, you can see from here that 42 models, and it's not simple models. They are very complicated models, probably too simple still, but nevertheless. And they try to simulate first what we observe 50,000. This is a temperature increase at the global level. And then you see you have two different, I was putting here only results of two extreme, more or less extreme results. One set of models take into account, it's not only, pure science or physical science, it's also social science, it's also economical science, it's also many things. And what they do is, what is the best way to do the modeling for the physics, and we have spoken about that. The second thing, when you would like to know what happened in the future, would be to know how the civilizations will work.
Существует огромное количество исследований в самых разных сферах. Это и физика, и химия, и исследования на тему, как же будет выглядеть наша Земля в течение ближайших 100 лет.
So you have two extreme picture. One is
И вот два совершенно разных графика.
The blue one, when you keep a very reasonable rate of change in emission, it's to say you really have to decrease your greenhouse gases emission to keep that. And also you take into account the evolution of the population, evolution of the education, many things. It's included a lot of things.
Голубым цветом представлено количество загрязнений, вызванных человеческой деятельностью.
And so basically this kind of models that tell you, well, it's still possible to have a global warming, because we will probably not be able to stop it, but maybe something around 2 degrees C, at the end, compared to 1900, about 2 degrees C. Okay?
В общем-то, представленной моделью хочется сказать о том, что даже если мы не сможем остановить глобальное потепление, то с этим возможно что-то сделать.
And the second is, well, we will work business as usual, not change, no way to to act in terms of emission, in terms of many things, and way of life, and so on. And then you are more around 4 degrees C, with a possibility in the extreme case to warm the climate by 6 degrees C at the end of the century. I don't believe it will be that, but 4 degrees C, yes, it's really something likely. Well, we have the choice, in fact. Or we have the choice. Yes, we have the choice. Okay, so let me continue. Sea level, it's also interesting. Sorry, for the second scenario, yes.
Есть риск того, что температура поднимется до 39 градусов, в чем я лично сомневаюсь, но тем не менее повышение произойдет обязательно.
Yeah.
И у нас есть выбор, мы можем сделать выбор, остановим ли мы это потепление или нет.
So for sea level, if we are reasonable, that's a way to summarize. Maybe an increase in sea level since today by about 60 centimeters, but we are not taking into account the fact that Antarctica and Greenland are now clearly showing something new, and probably it will be more than 1 meter. 1 meter, say 1 meter, that's it. But it can be maybe more. 1 meter, that's also an important parameter, is to say many countries are able to survive to that. Other countries are not able to that. Some islands clearly will disappear, if it is the case. Okay? And
вода в океане также будет однозначно подниматься. В первую очередь на Северном полюсе, в Антарктике.
Okay, so this is something we would like. The scientists, they are not delivering a lot of things, but at least, and they are not able to really to say to the people what will be the reality in 1 century. Okay, so they are just able to estimate a risk, and then societies have to decide and so on. But no more than a risk. That's clear, which is important. So what the scientists finally are showing for the next conference in Paris is the 2 maps you can see here. One is the 2 maps above, which is about temperature. This is about precipitation, but just focus on that. Here, if we are going to 2 degrees C warming, you see, you remember the scale, here it's cooling, so you have still some cooling here, by the way. Here is warming, still very important warming in the Arctic. I think all the models show that. That's absolutely strong and robust. Well, it will be warming, but as I said, around 2 degrees C. So personally, I'm not an expert to know what will be the influence of 2 degrees C warming on many things which happen at the level of the planet, except maybe sea level. For the rest, it's more difficult. Some nations will gain clearly, other nations will not. We can guess that geopolitical problem will become worse for quite obvious reasons. Well, that's we can say. But you know, then the second. Yeah.
Мы не можем делать предсказаний, мы не можем знать, как же будет с течением времени, но то, что мы можем сделать, это предупредить о риске. Говоря о Парижской конференции по климату, которая пройдет в декабре, там мы планируем выступление, которое как раз, на котором, в течение которого мы как раз и хотим продемонстрировать эти карты и сказать о том, что риск сильного потепления и поднятия уровня воды в океане очень велик.
On the other hand, you know, the map for 4 degrees C or a little bit more is really red. So I have no comments myself to do about that, but the only thing I think if we are talking about this Paris conference in next December, which so all the UN nations will be part of that. It's to say more than, I could not remember, but under 30 nations in the world, most of the nations in the world in any case. They will have to, well, they will have to look at that and then say or try to say a little bit, or not a little bit, to say, well, what we would like to have and how we can do that. So I think that's the aim of the scientists no more. That's very clear. On the other hand, you know, so I think the question in Paris will be, do we prefer a world at 2 degrees or do we prefer a world at 4 degrees? To simplify, you know, it's evidently more complex, but just to put stones, you know, a boulder as we have in the Alps, and say, well, it should be between 2 boulders. We should not go right or left of these boulders. Too quick.
На конференции в Париже будут представители объединения, представители ООН и представители разных стран мира. Именно там нам предстоит ответить на вопрос, хотим ли мы, чтобы мир потеплел до такой предполагаемой температуры.
Okay. One last thing about Paris, it's a personal feeling. I have the feeling the way it has been organized compared to Copenhagen or all the others is that the approach has been different with nations. I think they asked, I was not part in any of these decisions, but the feeling I have, they ask each nation not what you should do this and this, no, but they said, what do you propose yourself inside your country with the specificity of your country, and it's clear each country has a different challenge in this story. What do you propose to do? So I think already more than 50 nations responded. I think Russia did, many others in Europe and so on, and China, okay. And so I think maybe it's also a hope that this conference this time will be maybe a little bit more efficient, maybe more efficient, and I hope very efficient, that's for sure. I know that I'm too long, but I would like just to show you one or two more things. Of course, as you know, it is an international panel of experts on climate change, which is a panel which has been formed by nation, asked by nation, starting in 1988.
Что мне кажется особенно интересным в Парижской конференции по климату в декабре, это то, что соберутся представители разных стран, пока заявлено более 50 представителей, в том числе и Россия, и Китай. И хочется задать вопрос каждому народу, каждой стране, что можно сделать что вы можете сделать именно в своем государстве. И еще я хочу поговорить о межправительственной группе экспертов по изменению климата, членом которых я являюсь.
And this panel is formed by experts. Experts means people who were working in the lab about climate change, who were modeling the climate change, who did crush the ice, for instance, in the lab. No, I'm teasing. But yeah, people who really did something. And so there are since the beginning, about 2,000 people. It's not so many experts, in fact, in this field. And they are not asked by the nation to do science. They are asked, when they are in the panel, to write the state of the art of the knowledge if 4 or 5 years. So they evaluate in the conclusion, definitely. So that's one thing I would like to point of view. I had a lot of things to show about that, but I will not because I am too long. One thing...
Эта группа состоит из экспертов, из ученых, которые на протяжении многих лет работали над проблемами изменения климата. Группа не такая большая, она состоит из приблизительно 2000 человек.
And you know everything about the Nobel Prize. You can summarize that?
Yeah. За работу этой группы была назначена Нобелевская премия, но что особенно интересно, Нобелевская премия не по физике, не по химии, а премия мира. Это очень важно отметить, так как действительно результаты работы внесли огромный вклад в понимание того, что ждет человечество в ближайшие 100 лет. Какие риски и насколько они велики.
Yeah, спасибо. So we will. I skip all this. Okay. Well, that's an interesting calculation, not this one. This one.
И вот очень интересные результаты подсчетов.
Sorry, it's in French, but.
Простите, это по-французски.
If we would like, that's a sort of easy calculation. If we would like to keep the global warming to 2 degrees C since 1900, we are allowed since 1900 to emit 790 billions of tons of carbon. Okay? That's what we are allowed to do if we would like. Okay. So until now, 2014, we emitted 545 already. So we have still in our pocket 245 billions of tons of carbon. Today we emit about 10 each year. So we have still at this rhythm about 25 years. Okay, that's very simple calculation, you know, at the level of the primary school. But sometimes, you know, in primary school, we say quite nice things also. That's okay.
Эти данные говорят нам о том, что если мы хотим приостановить глобальное потепление, то мы должны редуцировать количество выбросов углекислого газа в атмосферу. Это очень простые подсчеты, как в начальной школе, но иногда начальная школа тоже может быть полезной.
And then I would like to finish on another subject. This is, and I think here in Tümen there are some people interested in this. How we organized our Russian-French venture about working on ice core. So
И закончить я хочу разговором о том, как мы организовали наше русско-французское сотрудничество.
Yeah. So the start was definitely, you know, when the Soviet started, they had, you know, very nice view of priorities, and they said, we are in Antarctica, we have good drillers, we will do our best to drill 1 or 2 or 3 ice cores. In fact, they drill until the bottom, including to the lakes. That's another story. Later, if some people are interested, we can speak together about that. But, okay. And so they got this wonderful ice core, which has still a lot of secret to deliver. And because at this time, you know, they made priority on other fields, study of the space, things like that. They were looking at collaborative work to make measurements, CO2 measurements, or any kind of measurements on the ice core, because they had not a lab devoted to that. And, well, finally, a wonderful link has been made because of 2 people, in fact, one Russian and one French. And they decided, well, why not to put the effort together for the lab's story. And it started, you know, to make the people work together unofficially, in fact. You know, it was nothing official at the beginning. And finally, it was a long story, but the end of the story is the period since 2002, I will say, where progressively we build a sort of international lab, but which is in fact a Russian-French lab, without building, you know. The buildings are in St. Petersburg, some are in Irkutsk, etc. In France, that's also the case. But which was making that the people first were meeting, and that's all these photographs that you can see here, we are meeting each year. Okay.
Инициатором этого проекта выступила Россия, точнее Советский Союз в то время. Они уже начали исследования в Антарктиде и успешно добывали ледяной корм. Однако они искали сотрудничество, международное сотрудничество и нашли в лице некоторых французских ученых. Таким образом сформировалась русско-французская группа исследователей, которая сначала работала неофициально, но это был очень долгий процесс на протяжении многих лет, по результатам которого была создана международная лаборатория, и встречи проводятся и по сей день, встречи исследователей, работающих над ледяным корном.
Yeah, and so it has been very effective. I think without too much money, it's a very cheap program, I would say. But one other very nice output of this story is that in St. Petersburg at RARI, Arctic and Antarctic Research Institute, they build, that was not so easy for them to do that. They built recently, over the last 4 years, a real lab to look at ice core and also ice from lake ice and so on. And I think it's very nice to show the dynamics of this group and to see finally that the fact that we have this exchange, we have PhD, joint PhD studies and so on. So that's, well, I would like to finish because I was too long about this nice story in any case. And sorry not to have been so nice as I thought I would have been at the beginning.
Очень эффективна была работа этой группы. Проект был недорогостоящим, поэтому удалось сэкономить большое количество денег. Научно-исследовательский институт Арктики и Антарктики в Санкт-Петербурге продолжает работу, является курирующим институтом. И была построена большая лаборатория, которая как раз и занимается исследованием ледяного корна. И очень интересно наблюдать динамику развития этого проекта и динамику исследований. И в целом радует успешность работы группы и результатов этого проекта.
Спасибо большое.